is Dockter. I'm the founder of Gradle, based in Berlin, Germany, and I'm also the CEO of Gradleware, which is a company behind Gradle providing services. I will talk a little bit more about that later. So this talk is not just about the new Android build system, it's also about the patterns we are using for that Android build system and how we think they're valuable for many other domains. So why are build systems important? Why did so many people show up here? It might be me, it might be Gradle, right? So there's a broad continuum of challenges in the build system space. So where Gradle has a strong focus on are large software stacks, right? Real heavy lifting in companies like Goldman Sachs, like LinkedIn, who have a 3,600 submodule Gradle build, right? And automation requirements on that scale are very complex. And the existing tooling is just far away, the legacy tooling, from really taking these challenges. And this was originally the main motivation for Gradle. We want to do the heavy lifting for the complex software stacks that are out there. So this is important to understand where Gradle is coming from. And for projects of that scale, this is not a nice to have feature to have a good automation. This is sometimes a question of survival. Seriously. I mean, I can tell you one example. So we involved with one company, 500 developers on a Java, C++ code base, 15 years old, 50 components, 20 teams distributed Europe, United States, and India, and 1 year. Right? Build time, 15 to 24 hours. When should someone commit in the US? You know, when can the feedback cycles? It's a disaster. The problem is this is a hard problem to solve. There's no free lunch out there for them, right? But so they're doing stuff like they tried to do some continuous integration effort, but it didn't work out. They basically lost the capability to build an ear, that is working, that they can ship to QA. It took them weeks with a massive effort to get 1 year out, and then another couple of weeks. So the whole delivery process was broken. They're shipping software for a living, right? This is not just some internal provider for a bank. They're shipping software for a living. So then they went back to single build pipeline approach, and they always have a successful build. How do they do that? They have one nightly build, and they started at 7 p.m., and if it fails, first someone in India is looking at it, 3 a.m. in the morning. If you can't solve it, or she, the build team is called in the US. If they can't solve it, they call the developers. This happens a couple of times a month, right? So for them, but they had to do this discipline at least to have 1 year per day that is at least buildable, compilable. It's a traumatic situation for them. They're on the brink of not being able to ship software anymore, right? So, and I can imagine WebSphere is involved, ClearCase, and whatnot, right? This is quite a movie that is going on there. So for them, it is a question of survival to solve that problem, right? So, and that's one of the areas where Gradle has a lot to offer, and where we will add feature after feature to tackling one of the largest stacks that are out there in the world. So just to give you some background, we had 1 million downloads now over the last 12 months. We have our own conference around Gradle. There's now 5 or 6 books out there. So Gradle is a highly adapted technology. So there was a life of Gradle before Android, right? And it's not just in the Java space, so we're now on our way to being a really good C++ build system, right? Which is very, very important market and user base for us. And when I give these talks to Android folks, they are more like, hold on, we are not this shipyard in Shanghai. We are more kind of a smaller team. Why should we bother about builds? We're just 10 people, right? Well, Gradle is not much bigger, right? But we invest a lot of time into our automation. It's not strictly as much a question of survival. Nonetheless, it's extremely important and valuable for us to invest into our automation. And this is not just about compiling and building your archives. So we
we do release every 6 weeks. And we have a massive user base, so we better not screw it up, right? So there is a lot of stuff we do for automation. For example, when we create a Gradle user guide with its 70 chapters and 600-700 pages, every code demo you see there is live tested. The output is extracted and injected into the user guide. So we make completely sure that the code snippets are up to date or the build fails, right? We can't afford to have a editor, that is going every 6 weeks through the whole user guide to see if the code demos are working. We say that with some larger enterprises, they are pretty loaded with money, so they say, QA will figure it out, right? So we can't afford that. So for us, it makes us really efficient. So when we do a release, all the website is updated. We have a massive fixture of tests to capture regressions, right? So we can anytime reproduce the performance of Gradle for very different scenarios for all the Gradle releases that are out there, right? So, and this is an interesting thing of this example. This is for the continuous delivery process, but this toolkit, for example, for our performance testing, we have a toolkit to create whatever kind of project you're interested in to do some experiments with as a developer. You can tell our build system, hey, I need a 1,000 submodule build where the nesting level is 4 with 100 dependencies per project, with a large source tree, with a small source tree. So that's another important aspect of build systems, not just the delivery, but provide the tooling to the developers to get fast answers to their questions, right? So, and all the website updates we have when we do a release and the emails we send around, it's fully automated. We have a one-click release, right? So, that gives us the capability to have a fast time to market, to release very often. So there's a lot of benefit, even for small teams, to do stuff to improve their automation and really invest heavily. Many postpone it, many startups postpone it, but I think you can't really afford that. By the way, what I forgot to add, for the larger projects, if you do your job, you have an enormous competitive advantage. I think a major contributor to the commercial success of LinkedIn is the amazing investment they did into their automation infrastructure, so that they brought their release cycle down almost to nothing, right, if they want to. So that gives them a massive competitive advantage. If you're in a competing scenario, you get, let's say, inspired by the features of your competitor. The competitor is doing the same. Well, who is faster in shipping that? And automation plays an important role in that. And then the other thing that is getting interesting, what we see in many organizations, they have this massive kind of build infrastructure, right? And then the Android teams and the iOS teams, they work on little islands, not fully integrated, right, with the other stack. And that's not good, right? So because the Android project depends, for example, on many of the backend services. So the guys that are doing the backend services, they want to ask the question, when I do this change to the service API, does it break any of my downstream dependencies? So I want to know, does my Android project still work with that? So I want to get my Android projects fully integrated with my build infrastructure. And one key quality of Gradle is that it really enables you to embrace a very heterogeneous stack with Java, Scala, JavaScript, Android, and then to build up that integration feedback you want. Okay, so let's talk a little bit about the Android build system. So what is the Android build system? Initially, people thought, hey, Gradle is building the Android SDK. That is not what this is about. The Android build system is based on Gradle, which is, that's our opinion. And then the Google Android team is writing the Android Gradle plugin, which is basically a full extension of the Gradle platform to incorporate Android requirements, plus the IDE integration, Android Studio. That's done by the Google Android team, right? The IDE integration is based on IntelliJ, but Android Studio is developed by the Google guys, right? So, and this is a really magnificent piece of engineering by the Android team. So for us, I mean, in general, of course, it's a really nice story that Google Android is using Gradle, but I'm even more excited about how they're using Gradle. So this is not just some other build system for a particular platform. This is absolutely state of the art. They have evolved together with us patterns that I think are state of the art patterns where other platforms could benefit a lot. And I will talk about that very soon. Okay, so one very important aspect of that new build system is that it's declarative. So this is a possible Gradle script. It's empty. So Gradle is a generic automation tool on its lowest level. You can do Microsoft Office automation when you want, right? You could start the end way. Let's create some task, right? And it does whatever you want. So we have this low-level execution layer. But now I'm having an Android project, and I don't want to do the end way and copy and paste some build XML into my project. So I have an Android project here. My code base lives in source main, and my testing lives in instrument test, right? So how can I build that? So this is the simplest Gradle Android build that is out there. Let's do a refresh here. So you just tell Gradle, hey, this is an Android project, and you specify some constraints. And what you can see here now, you have now a full life cycle of dealing with this Android build. So let's switch to the command line. And let's ask Gradle from the command line what you can do with this project. And we have a nice filter here. So if you look at this, you can do the standard stuff, right? You can assemble, you can build your APKs, you can install it to a device, uninstall it from a device, you can run your instrumented test, and that's it. Nonetheless, Android, and most of you know, is a very complex workflow. 10 times more complex than any Java project, right? So, and if I show this to some Java folks, they're wondering, what is so complex there? This is a normal life cycle. Well, then I say, then let's have a more detailed look of what is happening under the hood. Here we go. Render script, ADI handling, resource processing, dexing, pro-guarding, and so on and so on. It's very complex compared to what you have to do in Java. The first thing you can see when you look at this, one major goal of Gradle is to hide unnecessary complexity for a normal developer. It's a big problem with Ant. That's also often a big problem with Maven, right? So yeah, you could now build this project, build the APK. So that is the first example of how Gradle is declarative. Declarative means you say, I have an Android project. All the tasks, all the how, what you want to do with this Android project is created for you by Gradle. You don't need to bother about the how, right? You only need to say, I have an Android project. So, but the world is a little bit more complex than that. You have certain typical requirements where you want to have some flexibility, and one key quality of the Android plugin is how this is modeled. A typical requirement you have is that you want to have slightly different versions of your APK for debugging, possibly for staging, and for releasing, right? So for debugging, obviously, you want to have a very fast build cycles. You might not want to have any ProGuard enabled, but the debuggable flags and the native debuggable flags should be set to true. For the release, it's the opposite. So by default, the Android plugin adds two build types, debug and release. But hey, we have my good friend Dick Wall. He wants to have Scala on Android, right? He is desperate for that. So, but the problem, as you know better than I do, is you need to ship the full Scala distribution with the Android app, right? So pro-guarding is very important, to shrink it down to the maximum. But you pay a high performance price for that. So he doesn't want to do that for debugging, but when the stuff comes to QA, he wants to have a staging build type where he can exactly do that. All the debuggable attributes should be set to true, but pro-guarding should be enabled to give them an application that is very close to what is going shipped to the clients, right? So build type, a typical problem, not just in the Android world, but here it is really nicely solved. Let me show how. Let me show you how. So from very basic to basic. So So here you can see the Android plugin is adding the debug build type. And we just reconfigure it for our build. Set the package name, suffix, and stuff like that. And then we say, hey, we want to have an additional staging build type, right? Where we set all the debuggle to true, run program to true, and all the stuff you want to do, the signing config and whatnot, right? So that's now let's look at this build. Let's say Gradle task. And here we go. Declarative power in action. You see now there is now an assembled staging task, right? That is building the APK for the staging, right? There's an assembled release task and an assembled debug task. Those are the build types added by the Android plugin. And the nice thing is you can also say, hey, assemble everything, right, for the CI build or whatnot. So you can choose which stuff of the output you want to have built, right? And there's an install task, there's an uninstall task. And now what you can also easily do by adding a staging build type, you now have a staging compile dependency scope. So you can say, hey, my staging build type needs a special external library, it's commons.io. So you have full external dependency management that you can make very specific to the build types, right? So, and the developers don't need to think, hey, how do I model this to Gradle? You have a language element where you can model that very easily. So that's one thing they added, very helpful. I saw quite a few, ambitious Android projects where they try to do that with Maven, with all the Maven profiles on CI and all that kind of stuff. It's getting easily out of hand, right? And definitely not easy to use for the developer, right? The next concept they added, another typical problem you have with Android application, for the build types, it's still one application you're shipping to your clients, right? And you're just modeling the delivery process with the build types. Now, what you very often have in the Android world is that you have flavors of a particular application. It's the same application with a different flavor, a free flavor and a paid flavor, right? So that's another thing they wanted to make very easy to be dealt with. Here we have an Android application, right? And in main, there is the main code of the application. And then you can say, hey, I have a free flavor and a paid flavor. And you now have, we call it a dynamic declarative element, this kind of stuff. We now have build by convention in place, right? So if you now create a source free directory, you can put in resources here, you can put in code here, and then this code is automatically added to your paid APK, right? You can also add specific tests for the paid flavor, and they're automatically picked up, and you can run them, and you don't need to bother about anything. You just put your test into instrument test paid, and you can execute them, right? And they're run against the correct APK. By the way, the same is true for the build types. So if you have specific resources or code for specific build type, just create source debug or source staging, and it will be automatically included in your APK, right? So that's another, I think, problem that is very elegantly solved. You now have a Cartesian product, right? You have the trousers, which are the build types, and you have the version, the flavor, free or paid. So two different dimensions, right? And that's what we call a build variant, right? So, but what is if you're now getting sunglasses into the game? Another dimension. What would that other dimension be in the Android world? Just some ideas? Android version, App Store. Yeah, absolutely. App Store. Intel is saying hello to the mobile world more and more, right? So processor type, device type. Some of that you can handle with, the device type. There's some flexibility in Android itself to deal with that, but sometimes that's not enough. So there might be many variants. So that's another elegance of Gradle. This is not where it stops, right? So you can add as many dimensions as you want, and we will soon see how you do that, right? So you now have, we now have here 3 dimensions. We have the free and the paid, we have x86 and ARM, and we have debug and release, right? So let's see how you can model that with Gradle. Here we go. So here we have the product flavors, and here we specify a flavor group. The flavor groups, when you have more than one flavor type. So ABI is 1 and version is 1. Free belongs to version, paid belongs to version, ARM belongs to ABI, and x86 belongs to ABI. Right? And again, built by convention in place, so if you put your test in instrument test ARM, they will be automatically executed when you build this particular APK, and so on and so on. So if we now look what you can do with this guy, now I have quite a few of options, right? So there's now, you can assemble the ARM free, you can assemble the ARM free debug and ARM free release, but you see there's a hierarchy. You can say, hey, build me every APK, right? Or you can say, build me all the variants for the free ARM flavor, which means the debug and the release types, right? So there's a hierarchy where you can exactly choose which stuff you want to have built. Let's have another look at this build script. Look how small it is, how easy it is to understand what is going on here. I mean, this looks like something completely trivial, right? Of course, I have some flavors, right? Some flavor groups, everything is good. Now imagine you would have to do this with AND. This is the number of tasks that are generated by Gradle to deal with that. Right? It's more than 300 tasks. Imagine your build XML, how that would look like. It would be insane. Now, who of you is using Maven for building Android? How would you solve that with Maven? So a typical way to solve that would be to have a sub-project for everything, right? A sub-project for the main code base, for the free flavor, for testing the free flavor. You would easily have 50 sub-projects. But this is now a very important point. So first of all, it's a maintainability thing, right? It's way more complex. But this is not just about maintainability and how nice it looks. You want to, when this is not properly modeled, when you have this AND build or this 50 submodule Maven build, how can you say, hey, only run the tests for my free flavors? There's no way to do that. In Maven world, they're just a bunch of sub-projects, right? So here you have the proper abstractions. This is not just a convenience thing. You have a rich model of all that stuff, and you can now easily combine it and say, oh, run this subset of tests, run this subset of tests, and so the abstractions that you get out there are a key aspect of that, not just for maintainability reasons, right? So a key aspect of the Android plugin is, first of all, easiness. The Android developer should be able to describe what he or she wants to do in the terms of his domain. Build flavors, build types, product flavors, etc. The developer shouldn't bother about how can I map my requirement to the concept of a build system. This is done for you, right? And this is one of the beauties of having this rich model. You can think in your solution space, you don't need to think in terms of the build system. But there is much more to that. Once you have the abstractions, there's so much good stuff you could do with that. You could now easily write an Eclipse plugin, right, which asks Gradle, hey Gradle, give me all the different instrumented tests that I can run, and I want to provide a combo box to my developers. So once you have a rich model, the integration you can do with the tooling, because it is queryable, is so much easier. You get the idea, because the abstractions are there. You can't ask an AND build, hey, give me all the instrumented test tasks, or give me all the build flavors you're having, right? This is not modeled, they're just targets, right? It is not made explicit. The same is true for other build systems, right? That try to build Android in some form, right? So rich model is key for good tooling integration, but that is not where it stops. It's also key to extend it for your custom requirements. it would be so easy with Gradle to say, okay, we need some custom logic. We need to check for all the Android builds in our organization that, that all the free flavors don't use any commercial libraries. So you could now easily write a plugin, hey Gradle, give me the flavor container for this project, you iterate over it, there's a free flavor, let's hook in some custom checks what dependencies they're using, right? And it becomes, what with some build systems becomes an epic effort is a piece of cake, right? At the end of the day, this is what we're trying to do with our production code, finding the right abstractions, right? This is a key design challenge we have to do as software developers. In the automation domain, it's exactly the same, right? And when you have the proper abstractions, it's really easy to integrate the stuff, to extend it. So having this rich model is priceless, right? So one other nice aspect and another key reason why Google Android went with Gradle is an extendable platform with their own plugin system. So the Gradle Android plugin is a special plugin. It is the platform plugin, right? It is the base plugin. And now we see more and more automation plugins for Android requirements coming into existence that are based on the Android base plugin. So one example, who of you knows Monimo? They're providing Android virtual devices in the cloud, right? So, and they have provided a Gradle plugin. So when an Android plugin is used, they can now say, add also the Monimo plugin. And you have a little declarative element where you specify for which devices you want to test. That's the only thing you need to do as a developer. Now, if you now tell Gradle to run the instrumented tests, Gradle is not looking anymore for some local devices on your machine. It goes into the cloud, into the Monimo cloud, finds the right devices, runs your test in parallel on them, gets the test reports back. It's completely transparent for you, right? So, and the thing is, you don't need a build 10 pages in your build wiki to tell your developers how to run your tests in the cloud. They just need to apply the Monimo plugin, right? And you could do something similar for your own internal build farm if you want to, right? So, and we see a richer and richer ecosystem around the Gradle Android plugin. And because the Gradle platform is so extendable and provides so many hooks, it's very easy for those plugins to hook into the Android lifecycle to do the additional stuff and add the additional features. So that is a key thing that is enabled by that move to Gradle. And we're just at the beginning for that. So one thing I also want to show you are some of the core platform features of Gradle that are not strictly related to Android, right? But can be used by, a generic feature that is very useful in Gradle. So one thing we are offering is the Gradle wrapper. So we're going back now from Android to the Java domain. This is how you build a Java project in Gradle if it's simple, right? And what you can now do as the build master, you can say, okay, I add a wrapper task, right? This is a special task. When you execute that wrapper task, it produces output not in the build directory, but it produces output in your root directory. It creates a Gradle-W script, a Gradle-W bat script, and then in the Gradle directory, there is a wrapper directory with a tiny couple of kilobytes Gradle wrapper jar and a Gradle wrapper properties file. So let's look at that Gradle wrapper properties file. Here you can, okay, now let's go one step ahead. What you're now doing as the build master or the person responsible for the build, you're committing those 4 files to version control, right? The next time a developer does an update from version control, this developer doesn't need to have Gradle installed. He or she just uses the Gradle-W command, and then Gradle is automatically downloaded and provided to the developer machine. So there is zero administration on the client side. If you upgrade to a new version of Gradle, you just change the distribution URL. The next, you commit it to version control. The next time they do an update from version control, they're using the latest version of Gradle. Right? So zero administration on the client side, no phone calls. Well, my Gradle build doesn't work with Gradle version 1, whatever. You say, well, very interesting, but used to wrap up. There's another aspect to that. Build reproducibility. So we have clients that using Gradle to build embedded software for their medical devices. They ship those devices to hospitals. They get auditings. When an auditor comes and they can't show that they're able to reproduce, to rebuild the software they have put on those devices, they have to call back those devices. So for them, being able to specify that in version control, an important part of your build environment, is very important, right? There's other stuff we do to enable you to nail down your build environment. So for some companies, that's very important. For others, it's not so important. So it's a domain, it's a question of the domain. Right, that's one thing I wanted to show you. And the other thing I wanted to show you, and at the end, this will be a powerful shared concept, is the concept of Gradle init scripts. So let's say, again, we have a very simple Java project here. It's called Testing with Gradle. The first thing I want to show you how you can inject from the outside behavior into your Gradle build. Right. We start with something very simple. We define the repositories where to get the external dependencies from, right? So what we're now doing is we're cutting this out. And now we're creating what we call an init script. And yeah, don't bother about all projects. We'll talk about that later. And here we specify that behavior, right? And now we can go and execute this project build. Just let's run the tests, right? And if I would stop here, the build would fail. Gradle would tell, hey, I have no ideas where to get the dependencies from. Gradle is repository aware, so it doesn't, the local cache is very smart. It says, hey, I mean, I have those artifacts, but I don't know what the repository was, so you have to figure that out, right? There's something not in shape. But we can inject this behavior where to get the dependencies from by injecting this init script into that build. And what you can see is that the build is working, right? And you see the nice dynamic console output as well. Okay, so now let's do something interesting. Let's come up with something like, hey, I want to get a log message in real time if any of my tests are taking longer than 20 milliseconds. What about that? So in your init script, you have access to the Gradle build runtime that runs that particular Gradle build, right? You just access it via the Gradle object. This init script executes within the Gradle runtime, so we inject certain objects into that script that you can access. And then we tell the Gradle build runtime, hey, after you evaluated all the projects, in that case we only have a single project. If you have a multi-project build, it's more than one project. After you evaluated all the build scripts, right, give me the root project, iterate over all the projects. Again, in this case, we only have one project. Then I tell Gradle, hey, give me all the tasks of type test, and then hook a listener into those test tasks. So even if you have multiple test tasks, for integration tests, for whatever, you could do that, right? Then hook a listener into that test task that you get notified after a test is executed with the test results, and now you can calculate the time it took to execute the tests, and if it was more than 20 milliseconds, you issue a warning. A couple of lines of code, and now we go back and inject this behavior into that particular build. And here we go. Here we get the warning. Right. So, and this is pretty cool stuff. I mean, this is just one example that the Gradle API is very deep. So if you have custom requirements, and there are weird requirements out there in the automation domain. I mean, we had a user that was having one test, very important test, that was always failing when you run it the first time. You had to run it a second time. And if it then succeeded, it was successful.
So you can now laugh about those guys. Oh, you know, they're not very good software developers. You know who was in that team? The founder of Mockito, Stefan Faber. Very smart guy, now working for Gradleware. But it was the infrastructure team that was responsible for that. That was the reality. They don't need a build tool to tell them, hey guys, this is not a very good situation to be in. You shouldn't be in that situation. I completely ignore your problem. That doesn't help, right? So I would have never thought about that problem, right? And if we were just a framework that has a very strong opinion, we could have done two things. Yeah, wait for the next release of Gradle, then we might fix it. And we add a wonderful method, fail only after 2 failures. Completely screw up our nice API with all the pathological corner cases of the world, right? No, we're not doing this. This will never be part of the Gradle API, but hey, you have a toolkit. You can solve that. We understand your problem. You need the help of Gradle to solve that. And they could hook into their test execution process with Gradle to say, if this is this particular class, right, let me know. If it has failed, then execute it another time, and so on and so on. They could even write a Gradle plugin around that so that this behavior is automatically applied to all the builds, whatever. They can make this concept a first-class citizen for their organization. If that's what they need. And there are many unanticipated requirements out there. So as a tool, as a build tool, you have to embrace the unanticipatedness of the domain. Right? So there's another thing you can now do with Gradle. Every Gradle distribution comes with an init.d directory. It's empty initially, but you can put stuff in there. You can put init scripts in there. So what I'm now doing is, I'm now putting an init script in an init.d directory of my local Gradle distribution, right? So my init.gradle, and I'm pasting the same stuff in here, and now I can run. Now for every build that I execute on that particular machine with that Gradle distribution, this init script is injected into each and every build, right? So, okay, so you could now wonder, hey, is it a good idea that you kind of ask your developers to do something with the local Gradle distribution? Probably not, but yes, please.
In Gradle terminology, what is a snapshot?
Oh, I love to talk about that. In Gradle terminology, what is a snapshot? Can we talk about this after this example? Right? Then we talk about dependency management, one of my favorite topics. So the thing here is you don't want the developer screw with the local Gradle distribution, but remember the wrapper? You can now create a Gradle distribution. You take a Gradle distribution, put the init scripts that are important for your company to pre-configure the build environment into the init.d directory, and then let the wrapper point to that distribution. Then every developer automatically gets a pre-configured build environment, right? You can inject the repositories, you can inject any kinds of rules that should work out of the box, right? And the injection of the init script is also an interesting capability. So for example, some stuff should be just available out of the box. Other stuff you only want to inject into certain environments. Let's take as an example repositories. You could easily create in Gradle a rule, hey Gradle build, give me the repositories container, and you check which repositories are used in that build. And if there is a repository that is not the default company repository, you can let the build fail easily. If you have the abstractions, right, this stuff becomes really easy. But you might say, hey, for the local developers builds, they should be able to do experiments. They should be able to add any repository they want to play with. But as soon as they commit it and it's built on CI, I want this rule to be injected, let the build fail if there is a repository that is not authorized, right? So, and this is the beauty. You can easily inject features for different environments, and the deep API of Gradle makes it so easy to check any kind of stuff. What repositories are in there? What build flavor, what product flavors, what build types. Oh, Gradle, tell me about the dependencies. If there's any dependency that is on a blacklist, let the build fail on CI, right? You could go crazy. The French Academy of Language, Fred, could say, hey, if any task name is not in French here in this organization,
fire the guy, right? You can go crazy. So Gradle, the thing is, Gradle is a very powerful tool. It gives you a lot of freedom. But the key aspect of the freedom is to model your organization. Not that every developer starts going crazy with the build, right? You want to make it easy for them, that they don't need to mess around with the build. But I can't make too many assumptions of your organizations because they will be wrong, right? Here you have a toolkit to model the rules of your organization. So I get soon to the Maven snapshots. Another thing, it's small stuff but very helpful stuff. You can have a Gradle properties file that is project specific. That's not spectacular, but you can specify, for example, the Java, the JDK that should be used for running Gradle. You can specify the JVM arcs for running the Gradle build for this particular project. No build wiki that tells developers end op should be set like that, Maven op should be set like that. That's one of our mantras, no build wikis, right? And we try to offer you stuff that this is not required. Besides that, it's now version controlled. We talked about the advantages of that before. So, Maven snapshots. In general, dependency management is a domain that is still, I would say, in its infancy. So we have some solutions in the Java space. It's either Ivy or it's the Maven POMs. And they did a reasonable job for solving some of the problems in the Java domain. And now other domains are really challenging the concepts. So we're now working for C++, for JavaScript, for Android, for Scala, right? And they need a more powerful dependency management. For example, a typical situation you have in Scala or in Android is that you say, hey, I need a certain variant of my library. In Scala, you say, I'm running on Scala 2.10, right? Now, in my whole dependency graph, I depend on another Scala library foo, and I want now a dependency management that knows, oh, this is a 2.10 context, so pick all the 2.10 Scala libraries, right? The same is true for the Android build types. Give me all the debug stuff. Let's not start talking about C++, right? Which is, even more complex in that respect. So that is one area where we're working on, where we're also working on together with the TypeSafe folks from the SBT folks to have a good solution for that. Maven snapshots. What I really loved most when I was using Maven, when my artifact got promoted from development to QA, to take a break and then change all the POM XMLs, turning the snapshot dependencies into some fixed version, right? I'm joking, right? So Maven snapshots, they're trying to solve a real problem. You want to have continuous integration automatically between your binaries, right? There are different approaches, like I don't know who of you knows Bundler, where you basically always have to say manually, hey, give me the latest. But Maven snapshot is just not the right solution for that. We support Maven snapshots, right? But we don't think it is the proper solution. And one major reason is, a couple of major reasons. First of all, do a git bisect, to solve that problem. Hey, was it a new dependency that came into the game? The build script has no idea what this particular Maven snapshot meant at a particular point in time. You get the idea, right? So, and the other problem is that once you promote something, you have to manually change all the POM XMLs from snapshot version to fixed versions. I mean, we know organizations, they have thousands of POM files. It's completely insane, and they're doing it manually, right? So, a key problem here is that with Maven snapshots, you're not remembering the information. Hey, I had the promotion build, and the promotion build was successful with that particular timestamp of the snapshot. If I remember that information and can inject that into the build, then I don't need to change anything. I know the situation where my build was successful and can now say on QA, these are exactly the versions you need to use. Right? It's such a common use case, and we don't have, and the right solutions are not quite, are not there yet with that approach. It's insane because everyone is having those problems, and it's some solution, but it has a lot of pain points, right? So was that answer good enough?
So one thing I'm really excited about is the IDE integration. So I think one of the patterns where I say Android is state of the art is how it provides you declarative abstractions to deal with your build. The other area where I think Android is going to become state of the art, but it's getting in shape, is the deep IDE integration. I talked about that once you have the proper abstractions, you can visualize it in your tooling. So let's see how this can look like. So here we have Android Studio. And here we have an Android Gradle demo project. And we have two product flavors, free and paid, right? And we have a source directory for the free flavor and for the paid flavor. Different resource configuration. One thing that is pretty cool, what you can see here, you see we have selected the free debug flavor, and you can see this is now blue. So free resources is active, paid resources is not active, right? Because we can have this rich integration. And now we can tell the IDE, hey, now let's do something else. Let's have a look at this wonderful application. Hello world, right? So now we say, switch to the paid debug flavor. You can see what the passion is for which flavor in that company. And you see, now those resources are blue, right? And I mean, this is just the beginning, but it took me a time to get Android Studio to work. When I first, I just, for this demo, got it to work today, the first time that I really played with it. And I was close to tears. I'm dreaming so many years about a really deep build IDE integration. This is just the start. It's already really cool. But this is just the start of the best IDE and tooling support for any domain that we are going to achieve in the Android world. And imagine now the problems if we wouldn't have had that mechanism. Let's say for the paid flavor, you need to do some really fancy customization, some special source code generation, some commercial tool that is doing some special shrinking. How do you want to tell this to your IDE, right? Now that the IDE is not doing any build actions themselves, they're just delegating everything to Gradle. And just doing what the IDE is good at, in visualizing stuff, etc., you will have a completely different IDE experience. And just to show you the log of this guy, you can see how after switching to the new flavor, Android Studio was calling out to Gradle here to generate all the resources and the sources and the manifest handling, etc., right? So it's amazing, and it's just the start, right? So it's all about the IDE shouldn't be a build tool, right? So your IDE feedback will be much closer to the canonical build you're running on CI. You have optimized performance, right? We invested a lot of time into making Gradle very well performing for Android. Soon we will start parallel capabilities and all that kind of stuff. That's something it would be very hard for an IDE vendor to compete with. And why should they? That's not where they should focus on. You have more automation. I mean, I've seen, especially in the Android world, there's a problem. You can have very complex integration test fixtures, right? So what I saw very often when integration test setup became complex, there was a build wiki page. Before you run the integration test from your IDE, you have to run this particular end task to set up the test fixtures, and then you can run it from your IDE, right? Now this will come out of the box because the IDE is delegating to Gradle to execute the integration test. We are still far from where we want to be. So at the moment when you do that from your IDE, you just get some pretty lame console output. The next step we are working on is that Gradle will send rich events to the IDE, and you have seen our testing events, so that they can give you the same wonderful visualization you're used to, right? Red and green and the progress report, but still the tests are executed by Gradle, all the test fixture setup is happening automatically. So you have more automation. You have more feedback. One thing I discovered, when it is hard to get feedback
for a developer, the behavior of the developer will probably be, let's get the feedback tomorrow. I have other stuff to do. Right? That is, if you don't make it easy to get feedback, if they have to do manual fixture setup, the frequency with which they're getting the feedback will be orders of magnitudes lower than when it's easy. Right? Yeah. Less duplication, the IDE don't need to duplicate build logic. There was a big problem for the Android team. They had to do all the stuff in the Eclipse ADT tooling and for the end build system. Right? So, tooling integration is a first-class Gradle citizen. So the IDEs don't directly integrate with Gradle. We have a layer in between that we call the tooling API to make it really easy for them to integrate with Gradle. For example, we do the provisioning of the Gradle distribution. We deal with back and forwards compatibility stuff, but there's much more powerful stuff we're doing. So within Gradle, you can programmatically influence how the Gradle build is mapped to the IDE. Let's look at an example. Why this is important. So, for example, LinkedIn is having a 3,600 submodule Gradle build. If they would import that into Eclipse with 3,600 projects, how long would the refresh take? What do you think? A while. Yeah, that's a safe bet. So I would say more than 8 hours, right? So, so completely impossible. So what to do? So Gradle has internal models for all the IDEs, for Eclipse, for IntelliJ. And when you say, hey, Gradle, map that project to Eclipse, what we do, we create that model that represents the Eclipse world and auto-populate that. But then you as a developer can say, hey, Gradle, don't send it to the IDE right now, give me that model. And you can go to this model and customize it. Because the IDE, it's a lossy mapping. Eclipse has only one class path container and not multiple scopes. So there is no perfect way to map from a rich model that Gradle has to a lossy model of the IDEs. We do a good job, but you can tailor it. Very powerful stuff, right? And so we have, so IDE integration, we invest a lot of energy into that. The Google team is investing a lot of time into that. The IntelliJ folks, and we on the Gradle side. So exciting stuff will come out of that, right? And it's the first time that I say I'm getting Android Studio is on a level that I say, we can start using that in production, right? And there's much more to come. So you had a question.
Yeah, you had a question.
The question was, I only talk about Android Studio integration and whether there is an Android Studio plugin for Eclipse. No, Android Studio is, I would say, a special variant of IntelliJ, right? So what will be possible with IntelliJ 13, if you're not just doing Android development, but also development for other platforms, you can use Android Studio as a plugin in IntelliJ 13, right? Eclipse needs their own plugins. I think the Google Android team is still supporting the Eclipse ADT tooling, and they want to do some integration. For the details, you have to talk with them, right? So we have Eclipse integration with Gradle, right? But not with that tailoredness for the Android scenarios. So our Eclipse integration doesn't know what a product flavor is, for example, right? It's more for classical Java projects. So another exciting domain where we just started to do work in is deep CI integration. So the similar way you import a Gradle project into Eclipse, we want to make it easy to import a Gradle project into Jenkins so that Jenkins is automatically set up. You don't need to do some clicky-click to set up the Jenkins jobs. You just say, hey, this is a Gradle project, and we create the CI jobs that we think are appropriate for this project. Again, it will be customizable, like you've seen with Eclipse. There will be a Jenkins model and a CI model within Gradle where you can programmatically change the way it should be mapped. And so we're working together with the Jenkins folks. So this is work in progress. Can't promise when something regarding when we will ship it, but definitely something something cool that will be coming out of that. Again, I think this is really leading state-of-the-art functionality, a deep CI integration. I mean, running a build from CI, this is a boring thing, right? This is the real stuff, when it comes to build system and CI integration. Okay, if you want to learn more about the Gradle Android plugin, on the Android website, there's a decent user guide. We hope also soon that there will be a book, within the next six months, that there will be a book, how to use Gradle together with Android. If you want to learn more about Gradle, go to gradle.org. If you want to enjoy London October weather, come to the Gradle Exchange. If you want to get notified about news around Gradle and Android, you can subscribe to our newsletter. We are very excited about our conferences. We had our first conference here in Santa Clara in June, right? So 2 days, 3 tracks, just all about Gradle. Xavier was presenting from the Google Android teams, and the LinkedIn guys and the Netflix guys were presenting. And soon, most of the videos will be out there. So if you're interested, just go to gradle.org or gradleware.com, and you will find a lot of interesting content. Then, I'm also the CEO of Gradleware. Hello world, give me your money. So we are providing in-depth Gradle and Gradle Android training. So the guys that are doing our services are the Gradle core developers, right? So for any service you need around Gradle and Gradle Android, we are very happy to help you. But that's not the only area where we can help you when it comes to Gradle, or where it comes to Gradle. We as a company are involved in some of the most complex software stacks on the planet, right? I mean, it's fair to say that. So we have a really unique knowledge about how to model your continuous delivery design pipeline. And that is often the first challenge you have. It's not a tooling challenge, it's really how do I want to model that? And there's a lot of experience we have, so and we can share with you. So just approach us if you're interested. Yeah, and that's it. Do you have any questions? Yes. So the question was, when you use the different build types, whether changing the package name should be a problem. Not that I'm aware of. There's a property in the build type, right, that enables that. So I haven't run into that issue. So then I would recommend you go to the ADT dev list. That's at the moment the forum to ask questions for the Android build system, and they're usually very good in answering those. There's also a lot of questions on Stack Overflow regarding Gradle and Android. You're welcome. Yes, please. So the question was, there are few companies that also have iOS builds. And whether we are thinking about tackling that problem because you want to have a unified build system. Yes, 100%. A key quality of Gradle is the heterogeneity, and every major platform is going to become a first-class citizen in the Gradle world. So what does it mean right now for iOS? There is an external Gradle plugin out there. I haven't used it in anger yet, so I can't certify on all its qualities. What it does, it wraps around Xcode tooling, right? So I know the LinkedIn folks are working on Gradle and iOS integration. So our roadmap to that is, I told you about the C and C++ support. That will be our toolkit for then having a really deep Objective-C integration. So yes, iOS is very important, and right now you can wrap around the Xcode tooling, which is better than nothing. At least you have one build system you have to deal with, and you can do all the cool customizations with Gradle you might need. But this is there's more to come, 100%. Yes, so the question was, is there integration with Gradle and Node.js? We have a JavaScript plugin. So it is good stuff. We're kind of C++, Android work. So our bandwidth is kind of, we can't make the progress that we want to make. But so it would be interesting to see what are your requirements. It might be good enough for what you're trying to do. So JavaScript is another, of course, major platform. I mean, some people, there's a Gradle Grunt plugin out there, to integrate Grunt into Gradle. So yeah, a similar answer, a better answer than to iOS. We have already more advanced JavaScript support out there, right? But there's so much more we want to do in that area. So the major milestones on the roadmap for the next years or year? Yeah, Retire? No. No, I mean, there's so much we are going to tackle, and in different dimensions. So I would say let's talk for the next 4 months, right? I'm pretty clear about the priorities. So making the C++ stuff really absolutely production ready, with all the performance optimizations we still have to do. Working on the variant-based dependency management that is important for Android, for Scala, for C++. Tackling further improving performance and memory consumption for the large builds. Having a Gradle plugin portal that is better than our current plugin portal, which is a wiki page. And and then beyond that, and the IDE integration. We will do a lot in the IDE integration space, not just for a lot for Android, but also improve the Eclipse IDE integration, and NetBeans has really good Gradle integration. So, what is the 2014 story? I think one big story for us is unlimited scalability, which means being able to fully distribute a build. So whatever you throw at Gradle, if you throw the resources at Gradle as well, we will scale, right? So the question is, you want to have a multi-module build that includes libraries and your application. And the default assumption of Gradle is when you have that it's a hierarchical structure, right? And now you're saying they live in a different location. A few lines of configuration in the settings.gradle. So you have a hierarchical structure which is completely separated from the virtual multi-module structure. We make an assumption about the hierarchical structure, just change it in the settings.gradle, and no problem at all. Very easy to solve that. Yes, please. So the question was, the Amazon deployment process totally sucks. Yes. So that would be a good feature, absolutely. That's why you want to have automation, not to bother about that. So yeah, I mean, of course, we're very open to that. The nice thing is with the plugin ecosystem, they could now easily contribute a Gradle plugin, even without talking to us, without talking to the Google Android guys, hook into the Gradle Android plugin and solve that. Okay, cool. Yeah, thanks a lot for your question. I really enjoyed that talk. Cool.